Welcome to Maths Bridge. Let's learn Java programming. Folks, please do visit us at our YouTube channel Maths Bridge. I think you are already subscribed to the channel. If you have not, please do subscribe the channel and then support us. Thank you and then happy learning. Here is our today's agenda. Let's look at high level, layered architecture. You could imagine when you are actually working on a Java application development, how the Java application runs on hardware, right? That's a question that we have to ask ourselves to understand the concept clear. So let's assume that you are holding a kind of a computer, right? So the computer means like a hardware. It comes with some operating system. For instance, in my case is like I'm using like a Windows operating system. The hardware and operating system together, I would rather call it as a platform. So I could also say like hardware platform, OS platform, or together can also call it as a combinationally platform. So there are instances where some of you might have Linux based computer, so hardware plus Linux operating system. There is a case where we have a like a hardware and then Mac operating system, Macintosh. So you have to see that like the platform means like a hardware and operating system combination is what I'm referring. Now the question is, when you build like a Java application, how the Java application runs on this platform. In case of C++, you will you are going to actually run it directly on native platform. But whereas in Java, what you have to have is like middle layer, which is called a JVM runtime. JVM stands for Java Virtual Machine Runtime Instance, which basically like uh, works like a virtual machine for your application, but takes care of like how your code runs on this platform. Java. Java is a objective-oriented programming language. A very well-known word is platform independent programming language. Why Java is a platform independent programming language, unlike C++? Let's look at this diagram which illustrates the concept of like a platform independence. Okay, first thing is like when we write a program, what you can see is like your file name .java is what you see, right, which is called a Java program. I just given one example, but you assuming that in your project you may have like multiple Java files. Okay, what you do, like you compile the Java code. So Java C is a compiler which takes a Java code and then convert into a byte code. That's what a compiler does in Java environment. Byte code means like a dot class. Every dot Java file, okay, takes as input and then converts into class file. So if you have like a 10 Java files, you may have like a 10 class files. Again, assuming that every Java file has one class in it. If you have more classes, then you will have those many class files getting generated upon your compilation. Okay, what this byte code means? This byte code is called as a platform independent code. Means this code that is being generated by the compiler in the context of JVM. It is not going to consider any hardware as a platform. When I say a platform, hardware Windows, hardware Linux, hardware Mac, this is called a platform. These are the three different platforms. Then what this JVM means? So Java virtual machine is nothing but a JVM. These JVMs is kind of like a platform dependent. So Windows has its own JVM, Linux has its own version of JVM, Macintosh has its own JVM. So platform independency can be achieved through the JVM. That's an architecture of Java. So it introduces a middle layer which basically abstract the underneath operating system hardware platform. So by saying that, you are now would definitely say that Java is a platform independent programming language. Once you develop a code and then able to compile and then generate a byte code, right? That means this code can work in any platform, right? Because JVM takes care of to run your byte code on specific platform, because JVMs are platform specific, but bytecode and Java code, Javac compiler, which is completely independent of hardware platform. All these operating systems, which I listed here, are known as a host OS, because this is the OS which we install on those hardware platforms. In Java, you mostly heard JDK, JRE, JVM words. This is a beautiful concept that one should have to understand what is meant by JVM, JRE and JDK. So we have seen that JVM means like a Java virtual machine. What it does, so Java virtual machine takes the class files as like a bytecode, convert that into a native machine code, which is hardware specific code, right? So when I say hardware specific, what that means, like the particular computer CPU executes that code directly on it. That's an idea, isn't it? So this is called JVM. So this JVM requires a class libraries, while executing the code, isn't it? So combination of JVM plus class libraries together, what we can call it as a JRE, Java Runtime Environment. Okay, JVM and plus class libraries together, you can call it as a JRE. So now you see the JVM and then JRE difference. JRE, right, a runtime environment to run the Java programs in a nutshell. So one more interesting thing that we have to see, JRE alone helps run the Java programs. You don't require all the time JDK, but if you are really developing any code, that is time that you look for the JDK. Okay, so now comes to a topic of JDK. What is meant by JDK? JDK means Java Development Kit, right? So I have captured a few highlights here. JDK is an environment of a software development used for developing a Java applications. Okay, JDK means JRE means JVM plus class library plus development tools like a compiler, debugger, Javadoc, key tool, and these are all. So these will run on the same software, right? So you can install JDK, because if you look at like our initial Eclipse installation, the part of Eclipse IDE installation, you also see like a JRE JDK getting installed in it, right? So the important keynote here is that you can install more than one version of JDK on same computer. It is allowed. So based out of your application, what version that you would like to use, you can still choose, okay, while compiling or building the code. Next thing, JDK consists of a private JVM, loader, interpreter, compiler, jar, archiver, etc. Now you see the difference between JVM, JRE and JDK. This is the most widely used, the question, and then you all need to just, understand the basic concept of what is meant by JVM, how you are going to achieve, platform independence, using JVM, how the JVMs are like in a platform specific, what is the roles and responsibility of JVM, and then what is mean by a runtime instance is called as a JRE, and then what is there inside JDK. Okay, this is a beautiful concept. I hope it helps. JVM architecture, Java Virtual Machine Architecture. Okay, so what is mean by JVM, and then what are all things that are there in the JVM is what you are going to see from this slide. So JVM is a Java virtual machine that enables execution of a Java bytecode, right? Java bytecode is like a class code, class files. So in JVM we have a class loader subsystem. What this class loader do, takes all the bytecode and loads the code into the memory. In JVM memory, that's called as a runtime data area memory. So we have a method area, heap area, stack area, PC register, native method stack. Okay, this is what the JVM memory. So method area means like Java, in Java what you do, like you are actually building like all the methods, right? So those methods uses like a method area as a text area, code area. Like there is a heap area because we have continuously working with objects, so objects actually occupies heap area. All the local variables requires a stack area, and there is a concept called a native method conversion, because your bytecode can be converted into native code for faster performance improvements, right? So that is where I think you have some space for native method stack. Okay, this is called a runtime data area. Now there is a one more unit called a execution engine. This is basically like helps you to run your code onto the hardware platform. So it has an interpreter, and then JIT compiler and garbage collector. So interpreter, that we know, right? It works like mediator between your high level code and hardware, because execution engine basically takes your code and enable to run on the hardware. What it does, like it is the responsibility of converting your byte code into platform specific code, right? That's called a machine code, and then run it, right? We have one more concept called a JIT compiler. So JIT means like a just in time compiler that converts a byte code to native machine code. So this happens at a runtime. So this is used for improving the performance of Java code when there is a time critical sections, right? For instance, so using JIT you can actually improve the performance of that piece of the code. So there is one more case called like converting code into native methods, native method interfaces is what you are saying, right? So JIT compiler needs them, so that's why like you are actually having two more: native method library, native method interfaces and all. See, the garbage collector is basically used for actually collecting the unused memory and then assigning back to the pre-pool memory of the system. Okay, so in a nutshell, JVM basically provides a runtime environment. It loads the code, it verifies the code, it executes the code, right? So in generally we'll ask a question like, why JVM? With the help of JVM, we were saying that Java is a platform independent code, because platform independency can be achieved through the JVM. JVM is basically act like a intermediate layer between your application code to run on hardware specific platform. Okay, performance improvement can be achieved through the JIT using JVM, and then JVM also has like a cross platform compatibility. This is one more important feature. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.